Hey guys, so here's what I'm doing today. I got this gear. Um, I didn't really take too many pictures of it, but anyway, this gear is for the auto feed on the apron of my lathe, and my lathe had a crash. I crashed it. It's totally my fault. Wasn't paying attention and crashed it. And what happened was couple of teeth got broken on this. Actually just one tooth, but the rest of them got kind of disfigured and mangled and all that. Well, after very tiresome internet searches, I could not find another one of these gears. My intention is to make another one eventually, but for now this is just to get me back up and running until I can buy a piece of this metal. This is phosphorus bronze. It's got a lot of copper in it. It's not a real hard metal, it's a really tough metal, but it cuts okay. So I don't have any involute cutters or gear hobs or elaborate gear machines and all these things that you see all over the place that people build that are just freaking amazing. I'm not that smart, or I don't want to spend that kind of time on it. I'm not really a gear guy, but I just want to fix my gear, right? So you can see how this gear has like this cup shape. The reason for that is this is a worm gear, and a worm gear works like this. You have, this is called a worm, and it's got a hole through it, and it has this shaft that turns round and round, and as this thing turns, it advances this gear. And for this to work, it has to mesh neatly into all the teeth of this gear, which it does. Now it didn't, because some of these teeth were just like pushed over from, you know, being bound up. Didn't hurt this gear because it's steel, but it did hurt this one. This is a softer material. I believe this is meant to be a sacrificial part. You know, you use the really tough part as the one you keep, and you make the other one out of something kind of weak, so it will fail, so it won't kill everything else, and then you just replace that one part. That's kind of the theory anyway. Now, this metal's not really hard to cut. You see the chips down here. That's what I've sliced off of it. And my goal is to just get these teeth back into an acceptable shape so that they'll mesh into this worm so I can drive my lathe. You know, it doesn't have to be hella perfect or anything like that. It'd be nice, but doesn't have to be. So what I've come up with is I have this thing here. It's called a dividing head, and the way this dividing head thing works is you can take and put something in here in the chuck, and you have different plates. See, they got all these numbers on them, right? And you use the plates with the holes in them, and there's a table in the book right here. See that? And you go through here and you say, okay, I want to take a full circle and divide it up. This gear is 29 teeth. Okay, so I want to divide up a circle into 29 pieces. So the way that works is, in the table, if you look here where it says 29, okay, that's the T, that's what you want, 29 teeth, right? The H is the plate that you use. So you use the plate with the 29 on it. See that? Okay. And then what you do is you advance the wheel. This thing, this handle, you turn this handle 40 times and you'll get 1 revolution on the chuck. So to get 1/29th of a turn, you turn the handle 1 time and then you advance it 11 holes on the 29 hole circle. Okay, so here's how that works. You have this thing here, it's called a banjo, and you set it. I've got it set for 29 holes. So I advance this. See, the other part came around. They're set in a particular orientation for this job. So I bring it around to this hole that the pin is in. See the pin? And so what I do is I grab the wheel here and I advance. Let me back up so you can see it all happen. 1 turn and then 11 holes, and we end right there at the 11th hole on the 3rd row, which is the 29 row. 1, 2, 3. Okay, so we have advanced 1 tooth. Now I'm not running this machine. I'm doing this all by hand because I don't want things to happen too quickly. So, and this is easy enough to cut. Now I've already cut this whole gear. It might take a little sliver. See that? Yeah. So basically what I've done is I've gone around this gear 29 times, and I took this is a boring bar for a lathe, and I put a little piece of high-speed steel and I ground a profile on here that's very much like a it's the same profile as this gear gap between the teeth. So is it perfect? No, it's not perfect. You know, is it a 1.5 module profile with a 20-degree pressure angle? Hell no. I'm not that good, but it's good enough. This is going to get my machine running good enough for me. Okay. And before, when I was working on this, you can see where I drew on this gear. Like this area here and this area over here, the teeth were messed up. In fact, you can even see the broken tooth still there. See where it broke off? Yeah. I could braze that back on. I probably will. I'll probably braze some metal in there and then use this jig to cut it the shape. You know what? I think I'm going to go ahead and do that. But I've proven to myself that this works. See how these teeth are not straight. They got about a 4-degree tilt. So if you look here, I've got the dividing head set pointing up 4 degrees, so that when we cut these teeth, you're not cutting straight across like you would a regular spur gear. This is a worm gear, so it cuts a kind of a concave profile by the rotation of this blade. See that? And it's cutting at a 4-degree angle, sloping downward. And that's so when this gear meshes in here like this, See that? They are at a 90-degree angle to one another, which is how they should be. And this gear can turn and push that other gear around in a circle and drive my saddle on my lathe. Clear enough? Okay. So I'm going to go ahead and braze that. Maybe I'll put the camera on for that. We'll see. So that's what I'm up to today. Alright, so we're just going to clean this thing up. I'm not going to try to braze any teeth on this. I put the torch on it and I didn't really like how that felt, so I'm going to buy a new piece of brass later and make a new one. But I'm going to let you guys hang out with me for a minute here while I clean up the rest of these teeth, and then you'll see what I'm doing here. So I just rotated it around, and that one's already been done, but I just put some heat on it, and I'm worried that I might have distorted the metal a little bit. I don't think I did, but we're just gonna, this is kind of like a clean-up pass, just to make sure everything still looks good. And it does. It looks really good. Yeah, very good. I'm going to call this and we are taking a tiny bit of material off on these passes, but it's not really changing the gear that much. Like I said, I've already shaped it the way I want it. You know, there might be a little bit of a touch, just a sliver being cut out, but it's not really hurting the gear. See, you don't need powerful machinery all the time. You know, I've been doing, everything I've done today has been with this machine off. All you need is a good jig to hold your work. Especially when it's really soft metal like brass. Brass is real easy to work with. That's the gap where the tooth is missing, which can't do much about that. Okay, I think we're going to call this good. This is the area where I heated up the gear. Alright guys. So I'm going to finish this up off camera, and I'll get you involved when I start putting it back together. Okay, well there it is. It's back in place. It's all engaged to the worm gear, and you can see how it works. When you run the machine, you got these 3 bars. You got this one up here, that's the lead screw for for threading, and then this one is for auto feed. It makes the carriage move much slower for cutting, and then this bar is just a control bar. This is how you turn the machine on and off. You turn it the other way to go in reverse. So you saw this one turning. I'm gonna point you back in here and we're gonna crank it up and you'll see it turn. So even with the tooth missing, it still runs pretty clean. And then on the controls, you got this handle here, and if you look at that, it says if you put the handle down, it'll make the carriage go left and right, and if you flip the handle the other way, it makes this top part feed in and out this way. Okay, so let me show you. You turn the machine on, got your spindle up there running, bars running, got it running really fast. Then we'll engage it, put it down. See the carriage is moving, right? And then when you run it the other way, you'll see this one moving. And that's what auto feed does, and mine works now. I've fixed it. So there you go. Hope you enjoyed that. I wish I'd given you more detail, but I tend to get into these things before I remember to get you guys involved. I just kind of, I like to turn up the music in here and just kind of zone out, but we'll try to do some more things later on. All right, well, take it easy. Thanks for watching.